Okay, so this is going to be a video on the octet rule. Hopefully this is a review. But let's start by saying what is the octet rule. Okay, first of all, its definition, all right? This is found, you can find this in the glossary. It's also in Chapter 7. Okay, it says that atoms react by gaining or losing electrons so as to acquire the stable electron structure of a noble gas, usually 8 valence electrons. Okay, so that sounds like just a lot of words to me. So, I mean, it makes a lot more sense if you see an example of it. Okay, so let's start by saying, all right, let's look at the electron configuration of sodium. All right, sodium's electron configuration is 1s2, 2s2, 2p6, 3s1. Okay, and what the octet rule said was that atoms react by gaining or losing electrons so as to acquire the stable electron structure of a noble gas. What it doesn't say, but I want to say, is that they react so as to acquire the electron configuration of the closest noble gas. All right. So if you take a look at the periodic table, all right, where's sodium? Well, sodium is right here. He's right there, all right? And his atomic number is 11, all right? Where are the noble gases? The noble gases are the far right column over here, okay? So this might be a little bit hard to see because it's on a different level, but if sodium is 11, which one of these noble gases over here is it closest to, all right? The one it's closest to is neon, all right? Neon's atomic number is 10, sodium's was 11. All right, so what the octet rule says is that sodium over here wants to achieve neon's electron configuration. All right, so what is neon's configuration? Well, neon has got 10 electrons, so 1s2, 2s2, 2p6. That's neon's configuration, okay? So the octet rule says that sodium wants to either gain or lose electrons so as to become like neon, all right? So what does sodium have to do in order to become like neon? It's got to lose one, all right? In order for this to become like that right there, it's got to get rid of that last 3s1 electron. So it needs to lose one electron, okay? Just for reference, I'm going to be abbreviating electron with the symbol E minus, okay? Just so that you know what that is. All right. So let's do something similar. All right. Let's say that you had fluorine. All right. Oops. Sorry. It should just be F. All right. So fluorine's is 1s2, 2s2, 2p5, okay? How does fluorine get from this configuration to this right here, okay? Because its closest noble gas is neon, all right? It's got to gain one electron, okay? And now what you do with this is you're going to say, okay, what happens to the charge of this atom when this happens, all right? So this right here is the electron configuration of neutral fluorine, okay? That's a pretty important point, okay? If fluorine is neutral, it has this configuration, all right? But what we're going to say is what happens to fluorine when this happens. If it's neutral and it gains an electron, which has, an electron has a -1 charge. If it gains an electron, it becomes fluorine minus. All right, it gains a negative charge. All right, a way that you can think about this mathematically is when it is neutral, it has a charge of 0. If it gains something, think mathematically. If something gains something, you're adding. All right. If it's 0 and it gains something which has a -1 charge, what is the charge that results? 0 plus a -1 is -1, all right? that's what its charge is. Okay? The best way to see this is just to do examples of it. All right. Let's try sulfur. Okay, the electron configuration for sulfur is 1s2, 2s2, 2p6, 3s2, 3p4. Right, okay? And sulfur wants to be, if you look at sulfur's location on the periodic table, sulfur is right here. What is the closest noble gas to sulfur, all right? For this case, it's actually 2 away from argon, okay? So the thing about the octet rule is sometimes the closest noble gas is going to be one that the atom gets there by losing electrons. Sometimes it's going to get there by gaining electrons. Okay, so argon. What is argon's configuration? It's 1s2, 2s2, 2p6, 3s2, 3p6. Okay, so here's the question. How does this get to here? Okay, this would involve, it would have to gain 2 electrons. If it's currently at 3p4, it's got to pick up 2 more electrons to get to 3p6. All right? So here's the logic. If this is the electron configuration when sulfur is neutral, then in the act of gaining 2 electrons to become like argon, what happens to his charge? If he's neutral and he gains 2 electrons, he's going to have a -2 charge. Okay? Mathematically, you could say, okay, if his charge was 0 and he gained 2 electrons, which is going to be a charge, each one's got a -1 charge, his resulting charge is going to be -2. All right, one more, and then we'll move along. Let's try calcium. Okay, calcium's electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Okay, calcium's got 20, that's 10, that's 20. Okay. What is the closest noble gas to calcium? All right, calcium's atomic number is 20. You can see argon's is 18. Calcium likes to become like argon. Argon, 1s2, 2s2, 2p6, 3s2, 3p6. Okay, so what has to happen in order for this to become like that? You have to get rid of these 4s2 electrons. If I cover those up, you can see that those configurations are exactly alike. Okay, so it's got to lose 2 electrons. So here's the logic. If calcium is neutral with this configuration, all right, if it loses 2 electrons, if it loses 2 negative charges, then its resulting charge is going to be +2. All right? Mathematically, when it's neutral, its charge is 0. If it loses, remember, if you want to think mathematically, when something loses something, that's the same as saying minus. If it loses 2 -1 charges, that results in a charge which is +2. All right. So the thing with the octet rule is there's a shortcut. If you go through this exercise for everything that's in this first row right here, all right, I'm going to write down these charges. Okay, you're going to find that you're going to have this pattern here. Whenever you do it for any atom that's in this first column right here, the alkali, those are called the alkali metals, everything is always going to have a plus one charge when it becomes an ion. All right, that's why when you have for sodium, if you think about sodium chloride, that's table salt, the type of ion that's in that is sodium plus one ion. All right, everything that's in this right here is going to have a plus 2 ion. Milk of magnesia contains magnesium 2 plus ion. There's one that's kind of an oddball. It's all by himself. Aluminum has always got a plus 3 ion. You could prove that by doing these configurations. Everything that's in this column right here has got a minus 3 ion. Oxygen, sulfur, those are always going to have minus 2. Everything here, these are the halogens. They're always going to have minus 1. The chloride that's in sodium chloride is chloride minus 1 ion. And over here, I say 0. What that means is that the noble gases generally don't tend to either gain or lose electrons because they already have 8 valence electrons, which is where they want to be. They have no reason to lose or gain. So they're always going to be, they're essentially never going to ionize. So we're going to be taking that and moving on to dot structures of the ions.